Welcome back. In this section of the course, we are going to see how we can use fundamental data structures called arrays in our programs. Arrays are really powerful because they allow us to store values of the same type together in the same container. In previous sections, we have used variables to represent our data, and we saw that this has been very useful. We know that we can store whole numbers as integers, such as a person's age in years. We can store fractions in floating point variables, allowing us to store item prices or the ratio of red apples to green apples in a bag. And we have other data types we can represent as variables as well. Using variables gives us greater control in our programs, as well as making our code easier to read. If I asked you to calculate the sum of 12 numbers, how would you do this using variables? Well, you would initialize each variable individually and then in one line calculate the sum of each variable added together. But this is just 12 numbers. What if there are 100 or 1,000? Using variables here is not going to work. Wouldn't it be useful if we could use a loop to achieve this? It would. And if we try to do it when we are using variables, we'll find that we have no way of referring to each variable inside the for loop. That's why we ended up summing each variable individually. This doesn't scale. If we wanted to add more values, then we'd need to change all of the code. In these situations, arrays are extremely useful. In processing, an array is a data structure where we can store a collection of elements which have the same data type. So an integer array would be a collection of integers, a Boolean array would be a collection of Booleans, and so on. If we use an array in the above example, then we can step through the array, accessing each value one at a time. Processing has the concept of static and variable-sized arrays. If we declare a static array, then we define a container that can store a fixed number of values. So if we created a static integer array with space for 10 integers, then we can't store more than 10 integers inside it. If we declared a variable-sized array, then the size of the container will continue to grow as we add more and more elements. The rest of this section will explore how we create static and variable-sized arrays, and then show how we can use arrays to solve more complex data science problems, such as finding maximum and minimum values, as well as visualizing more complex data.